Today we are going to learn about central tendencies and the effect of outliers on our central tendencies. Central tendencies may not be a word that you guys are very familiar with, but the measures of central tendency you may be familiar with, or you should be familiar with. We actually don't learn central tendencies in pre-algebra. We simply analyze the effect of outliers on central tendencies. So we will do a very, very quick review of central tendencies and how to calculate those central tendencies, but this is something you should already know and it should be a refresher. So when we are talking about the measures of central tendency, we're talking about mean, median, mode, and range. And so these are probably, oh yeah, we've heard those words. So you know these words, you just don't know that they're referred to as central tendencies. And the reason they're referred to as central tendencies is because they tend to gather around the same number, that central number. And they help us analyze trends in data. So there are four central tendencies. And here next to these, just as a quick review, you have how to find each of these. Again, you should already know these four central tendencies and how to find them. This is just a quick review. So your mean, or some of you may have heard this in previous years referred to as average. You find your mean or average by adding all of the numbers in a set of values and then dividing by the number of numbers in the set of values. So you add and then divide, and that number gives you your mean. And then you have your median. And I always tell my sixth graders, if you look in the middle of the word median, you have a D. And the only word that you have to remember to help you remember what the word median means is the word middle. And right in the middle of the word middle, you also have a D. So those are the same. And so maybe that will help you remember median is the one in the middle. So if you have a median, you have a middle value. So remember, when you're finding your median, you first have to put all of your values in order, least to greatest, and then find the middle number of all of those values. So the only time that this can get a little tricky is when you have two middle numbers. When you have two medians or two middle numbers, you have to find the mean of those two middle numbers. So you have to add the two middle numbers and divide by 2. Remember, this is a review, so this is something you have probably seen before. The only time you will have two middle numbers is when you have an even number of values in your data set. So when you are putting in order 10 digits least to greatest or 8 digits least to greatest. If you have 9 numbers or 7 numbers, you will have one middle value and you won't have to do this second step. But this extra step is the step that often my kids forget what to do when they have two middle numbers. Remember, when you have two middle numbers, you find the mean of those two middle numbers by adding and dividing them by 2. Your mode is the number that appears the most frequently in a set of data. You can have no mode if none of your numbers repeat, or if two numbers repeat twice and all the other numbers are there once, you can have more than one mode. That's called bimodal. So another little trick to help you remember what mode means is if you look at the front of the word mode, it starts with MO, and mode is the number that appears the most, and in front of the word most, you also have MO. Your range, or you guys may have heard this called your spread. And the reason we call it spread is as you get into algebra, range has a completely different meaning when you are talking about X and Y values, dependent and independent variables. And so when we look at graphing linear equations, you'll see the word range come up again, and you'll see it has a completely different meaning in linear equations and graphing linear equations than it does in data when you're talking about central tendencies. So a lot of teachers have gotten away from the word range and they use the word spread instead. I prefer that you know both words. I want you to know that in math, the word range has more than one meaning, And so we can talk about the range of a set of data. We can also talk about the spread, how spread out is our data. And so honestly, the word spread helps us understand the meaning a little bit better. But the range or the spread is the difference between the smallest value, the least value, and the greatest value. And so remember, when you're talking difference, you're talking subtraction. So you're subtracting the largest value from the smallest value. We're going to pause the video and copy these words and definitions into our notes and these little tricks to help us remember them. If you are 100% positive that you know all of this, blinded, hand behind your back, I could give you a test on mean, median, mode, and range tomorrow and you'd know these 4 words, then you don't need to copy it into your notes because this is a review. But I am going to give those who want to a few minutes to get it copied into their notes, and that means the rest of us need to sit quietly if we are choosing to not copy it into your notes. I will also tell you that if you choose to not copy it into your notes, do not ask the sub or myself for help reminding you what mean, median, mode, and range is, because right now I'm giving you an opportunity to put it in your notes. And if you're not putting it in your notes, that means you know it, and you better not ask for help remembering what these 4 words mean. So let's go ahead and pause the video now and take a minute and get this into our notes. So in pre-algebra, we are going to be examining the effects of outliers on mean, median, mode, and range. So first we have to understand what an outlier is. And it kind of sounds like, if you break it down, you can figure out what the word means. Outlier, something that lies on the outside. I like to think of an outlaw, someone who's not allowed in town because they're wanted for doing something they shouldn't have done. So they kind of stand out. So that kind of helps me remember what an outlier is. An outlier is a value that stands out from the other values. It's either far less or far greater than the rest of your values in your data set. So here we have a data set, 10, 6, 5, 91, 8, and 6. And so hopefully we see that the number 91 is far greater than all of the other numbers in our data set. So the number 91 is an outlier. So now we are going to look at how does that outlier affect the mean, median, mode, and range, and which one does it affect the most, and which one does it affect the least. Before we do that, I want you guys to take a minute and copy the definition and the example of what an outlier is into your notes. Pause the video here and copy this into your notes. So what we have here is the same data set that we looked at from the previous example with the outlier 91. We are calculating the mean, median, mode, and range of that data set with and without the outlier. So notice over here, we have the number 91 in all of our problems, which was our outlier. And notice over here where we do it without the outlier, we've taken the number 91 out. So without the outlier, to find the mean, we add 10 plus 6 plus 5 plus 8 plus 6 and divide by 5 because there are 5 numbers in our set. So our mean without the outlier is 7. Notice that 7 kind of falls in with the other numbers in our data set. 10, 6, 5, 8, 7. They're all kind of around the same number. They're very close to each other. If you look at the mean with the outlier, it's 10 plus 6 plus 9 plus 5 plus 8 plus 6. And divide now by 6 numbers because we've added in the number 91, and we get 21. Those two means with and without the outlier are very different. One is much more and one is much less because that outlier affects greatly our mean. It makes it much larger because it is changing the number that most of our values gather around. And so if you look at the number 21, you want to ask yourself, does 21 represent the majority of the numbers in our data set? The mean should be a number that is very close to most of your numbers and represents most of your numbers. And really the number 21 is not, because that outlier really affected and changed the mean. So not only does it have a great effect on the mean, but it also affects the ability for the mean to give us a good representation of our data set. So this number 21 isn't very useful towards us or for us when calculating measures of central tendency, because it doesn't represent the majority of the numbers. So let's look at median. We've put our numbers in order, least to greatest, 5, 6, 6, 8, and 10, and we've taken out the number 91. So we cross off 1 from each side, and here we have the median, which is 6. Here with the outlier 91, we have two middle numbers, 6 and 8. So we have to add those two middle numbers. 6 plus 8 is 14, and then we divide that by 2, and our median is 7. Does the outlier have an effect on the median? Well, it went from 6 to 7 and increased by 1, but are those numbers both still close enough to give us a good representation of our data set? Does the number 6 represent the majority of numbers in our data set? Yes. Does the number 7 represent the majority of numbers in our data set? Yes. So even though the outlier has an effect on your median, it is so minimal that it is still a useful tool in helping us to analyze a data set with an outlier. Our mode is the number that appears the most. Remember, when you have an outlier, it's only one number that stands out. So your mode is never going to be your outlier. So your mode is never affected by your outlier. It always stays the same. But mode is not always the best measure of central tendency just because it's not affected by the outlier. You still really have to think about what is the problem asking us for. Just because a number appears the most often, it doesn't mean it necessarily represents the majority of your numbers. Mode is one of those central tendencies that is not always useful unless you are specifically looking for the number that is there most often. It doesn't help us represent the majority of our numbers. It's not a number that most of our numbers tend to gather around. So it's not always the best one simply because the outlier does not affect it. So just keep that in mind. So far we know that the mean is affected the most. The median can sometimes be affected a little bit, but not a lot, by the outlier. And the mode is never affected by the outlier if there is a mode, because sometimes there's not even a mode. So then the last one is range. And if you really understand that the outlier is going to be your largest value or your smallest value because it stands out, and you understand that range is subtracting the largest value from the smallest value, you should know already that your outlier is going to have a very large impact on your range because it's going to be directly one of the numbers that we subtract when finding the range. So without the outlier, our largest number is 10 and our smallest number is 5. So our range is 10 minus 5, which is 5. With the outlier, now our largest number is 91, which is much greater than 10. We're still subtracting the smallest number, which is 5, and now our range is 86. So again, the range is greatly affected by the outlier. Always, always, always. So your mean and your range are greatly affected by your outlier. Your median has a minimal impact by the outlier, and your mode has no impact from the outlier. So let's pause the video and copy this table example into your notes. We will also copy a table in a minute that shows the best measures of central tendency and kind of talks about what we just said about mean being affected the most, mode not being affected at all, so on and so forth. So you don't have to worry about writing that right now because you'll see that table in a minute. So for right now, just copy the example and the math for calculating the mean with and without the outlier into your notes. Pause the video and do that now. So this is a summary of the results of the previous example, the conclusions that we drew, the outlier increases the mean by 14. So what I did was I just took the mean with and the mean without the outlier and I subtracted it. That's a very large impact that the outlier has on the mean. The median increased by 1. Again, I did 7 minus 6. Found that it increased by 1. That's a small impact. The range increased by 81. That's ridiculous. That's a huge impact. And it had no effect on the mode. So just based off the conclusions that we drew, if it has no effect on the mode, it's probably the best to use depending on what the problem is asking us for. That's always very important. Mean and range are affected the greatest. And for this reason, they are not the best measure to describe a set of data with an outlier. So I want you to take a minute and copy this conclusion into your notes underneath of the previous example that you just copied. Pause the video and do that now. So this is another really helpful little table to help us understand when each measure of central tendency is the most useful. Now, remember, this is not a blanket statement. You can't always just say, oh, if there's no outliers, I'm going to use the mean. You do have to look at a problem and analyze the information and what a problem is asking for when deciding which measure of central tendency is best. So typically when we are looking at the effects of central tendency, we will look at word problems. We're going to look at 2 examples of word problems here in a minute, and I think this will make more sense when we're looking at that. But this is just a very general statement, and it is very helpful to write this down. So we know that the mean is the most useful when a set of data does not have any outliers at all, because we know that outliers have a great impact on the mean. Median is the most useful when you do have a set of data that has an outlier. Mode is most useful. Remember, mode is a little bit different. So when it's specifically asking you for a value that occurs the most often, such as in election results, that would be when you use mode. So mode, it really doesn't matter with or without an outlier as much as it matters what is the problem asking you for. And then range is most useful even though it is affected greatly by the outlier. Again, it's most useful like mode depending on what the problem is asking you for. Range is not really considered a central tendency as much or as often as the other 3. So we only want to use range when it fits the situation of what they're asking us for, and if they're asking us to show how spread out that data is. So this little table is very helpful when looking back and trying to decide which central tendency is best for a situation. So pause the video and take a moment and copy this table into your notes, and then we are going to look at 2 examples together. So we are going to look at 2 examples together. We are not going to copy these examples into our notes because they are pretty lengthy because we're looking at word problems, and I think it's good to just start having these discussions together. Each word problem is different, so you really can't look at one word problem to help you with another. And it's really just about thinking through what is the information being used for. So the first situation we have here is the top 4 salaries for NFL players. And we're just going to look at the millions place. So we've got 35 million, 19 million, 16 million, and 16 million. And so hopefully you see that 35 million is significantly larger than the other 3, 19 and 16 and 16. So 35 million is considered an outlier. So this set of data has an outlier in it. So if we are looking for a number to represent what you could make if you were one of the top football players in the NFL, would looking at mean be an effective number to look at? And the answer to that is no, because you are going to end up making a whole lot less than what the mean with this outlier would be. This outlier would cause the mean to be much larger than it really is. And so we would not want to use the mean because it would give us a false impression that we would make more money than we really would. We want a number closer to what we would actually be making as a football player in the top of the NFL. So range is not going to be effective either, A, because there is an outlier, and B, because when we're looking for an amount that we would make, the spread wouldn't really help us. There is no mode, so that's not going to be helpful. None of these numbers repeat. So then if I have an outlier and I'm looking for an average number that these numbers gather around, the only other central tendency that I would use would be median. So we went ahead and calculated the median, and there is 2 middle numbers because there are 4 data points in this set. It's an even number. So you have 16,536,500 and 19,004,000 as both of our middle numbers. So we added both of those numbers together and divided by 2. So this median value, 17,770,250, represents approximately how much you would make if you were one of the top 4 players in the NFL. And if you look at these salaries, that's a better idea of how much you would make because the majority of these numbers gather around that median versus gathering around the mean. So that's an example. Again, when you're looking at an actual situation, it helps you to really think through which measure of central tendency would be the best. Now, like I said before, I'm not going to make you copy this down in your notes because it is a word problem. But if you do want to go back and look at the word problem, you can. It is on Canvas in your notes page on central tendencies. So you can see this again, and this video will be linked to Canvas as well. And you can watch this video again if you need to have a refresher and maybe a couple word problems walked through for you. But I will tell you that every word problem is very different. So it's really hard to look at one word problem and use it to answer the next one. Instead, we're just having the dialogue, the math talk, to start showing how you would think through some of these problems. So let's look at another example together. This is looking at data from the sales of a store during 1 week. So the first day of the week, say Monday, they sold $1,025 of inventory. The second day of the week, they sold $993 in inventory. The third day, Wednesday, they sold $1,001. Thursday, they sold $1,027. As we all know, most people go shopping on the weekend, so they made a little bit more on Saturday and Sunday. So on Saturday, they made $1,657, and on Sunday, they made $1,471 or $1,471. So when looking at this data, we have to decide which would be the best measure of central tendency to use. There's really not an outlier, even though a lot of my students think, hey, 1,657 is much bigger than the others. It is, but because of this 1,471, this is another number that is kind of much higher as well. And you can only have one outlier for it to be an outlier. So this kind of brings those numbers together by having 2 higher numbers. So what we do to figure out on this one, which one would be the best measure of central tendency, is we looked at all of them so that it's easier for us to decide which one's best. So we calculated the mean by adding and dividing by 7 because there are 7 days in the week. And we got 1,164. The median is 1,025 and there is no mode. So what we have to do is we have to decide which measure is best for representing this data, mean and median. And so then what we have to think about is we have to look at, well, what is this number going to represent? And when you're talking about sales, it's representing your average sales. And so do you want that number to look higher or do you want it to look lower? And so if you guys know anything about business or sales, you know that if your sales are higher, it looks better. So you want the number to be higher so it looks like your business is flourishing and doing better. So the higher number for your average amount of sales is going to be a good representation or make this store look better. So we would use mean for this situation because it's a little bit higher than our median. So in this scenario, the best representation is the mean because it's greater than the median. So it would look best because it makes the sales for the week look greater. So that's 2 examples of how we can analyze a set of data and determine which measure of central tendency is best to represent that data. Again, we're not going to copy this example into our notes, but you can rewatch this video if you want to talk it through again, or you can look at both examples on Canvas. So let's take a little bit of time together with what we have left and just practice identifying the outlier and the effects of the outlier on a set of data. Let's go ahead and get out a expo marker, and on your desk, the first thing I want you to do is I simply want you to look at this set of data and identify the outlier. Because if you can't identify the outlier, the rest of this is all going to be wrong, because then you're going to calculate the mean and median with and without the outlier. So let's take 2 seconds, pause the video, and give everybody a chance to write the outlier on their desk. All right, so hopefully looking at this set of data, we all see that the number 3 is our outlier. It is much smaller than all of the other numbers. So before we pause the video again, I want to show you guys how I would like for you to set this up on your desk. So you guys are going to do a little table because the directions say, how is it going to affect the mean, median, mode, and range? And so whenever you see this in your directions in your classwork, what it's asking you to do is tell me how much your mean, median, mode, or range went up or down. So you're going to make a little table on your desks, and you're going to do with, without, effect. And you are going to calculate what's the mean with and without the outlier, what's the effect. What's the median with and without the outlier, what's the effect. What's the mode with or without. So we actually are only going to do 2 of these practice problems because they do take quite a bit of time. And when you do your practice assignment, you only do 2. You don't do a lot because each problem is worth several points based off all of the different answers it's asking you for. So pause the video and let's take some time and work this out and calculate the mean, median, mode, and range twice. Once with the outlier and once without the outlier. And then what is the effect? Pause the video now and let's work out number 1. All right, guys, let's go ahead and start with calculating the mean with the outlier. So you should have added 35 plus 21 plus 3 plus 44 plus 36 plus 42 plus 29, and then divided by 1, 2, 3, 4, 5, 6, 7. And so with your outlier, your mean is 30. And then do the same thing except without. So we're going to do 35 plus 21. We are not going to add 3. We're going to skip 3. So we're going to add 44 plus 36 plus 42 plus 29. And then we're going to divide by 6 instead of 7 because now we didn't include the 3, so we only have 6 numbers. And now our average is 34.5. So that has an effect of 4.5 or 4 5/10. So let's go ahead and do the median. So let's put our numbers in order least to greatest. Over here we've got 3. I'm going to do it with the median, with the outlier first. And then we've got 21. And then we've got 29. Then we've got 35. Then we've got 36. Then we've got, I'm going to go down because I'm out of room, 42 and 44. So cross off, cross off, cross off, cross off, cross off, cross off. Our median with our outlier is 35. Without the outlier, I can just recross off. I'm just not going to include 3. So 1, 1, 1, 1, 1, 1, 2, 1, 2. Oops, I did that wrong. So here are my 2 middle numbers, 35 and 36. So I'm going to do 35 plus 36, and then I'm going to divide that by 2. So my median without my outlier is 35.5, and that only had an effect of 5/10. Very, very, very small effect. So do I have a mode? Do I have any numbers that repeat? No mode. So there's no mode with, there's no mode without, there's no effect on the mode. So then my range, I'm going to take my largest number, 44, and I'm going to minus 3. is 41 without it's 44 minus 21, which is 23. And so the effect is 41 minus 23. It has an effect of 18. Huge, 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 huge effect. So hopefully you guys see how much work is included in one problem. So if I was grading this, I would grade your mean, median, mode, and range without, each one of these would be a point. Each one of these would be a point. And each one of these would be a point. So that would be 12 points just on one problem. And it does take a long time to do a problem. So let's try another one. Again, you're going to do the same thing. Let's just start by pausing the video and identifying the outlier. So hopefully everybody is not having a problem at least identifying the outlier. Number 24 is much larger than the rest of the numbers in this data set. So 24 is our outlier. So then what we're going to do is we're going to do a little table with, without, and then the effect. And I want you guys to go ahead and calculate your mean, median, mode, and range with and without your outlier. Pause the video now and do this problem. So with the outlier, we are going to do 7 plus 5 plus 6 and 6 is 12 plus 24 plus 5 and 5 is 10 plus 2 is 60, and then divide that 1, 2, 3, 4, 5, 6, 7, 8. So with the outlier, our mean is 7 and 5/10. Without the outlier, I can just go back to my sum of 60 and minus 24, and then divide by 7 instead of 8. And so it's approximately, you have to round it, 5 and 1400ths. And then we can subtract 7 and 5/10 minus 5 and 1400ths. It has an effect of 2 and 3600ths. To find the median, let's go ahead and put them in order least to greatest. So we've got 2, we have 5, 5, 5, 1, 2, 3. Then we have 6 and 6, and then 7, and then 24. So 1, 2, 3, 1, 2, 3, and then we have 2 middle numbers. So we're going to add 5 and 6, which is 11, and divide by 2. So with the outlier, my mean is 5 and 5/10. Without the outlier, we've got 1, 1, 1, 1. I skipped that one in the beginning. 1, 1. My median is 5 without the outlier, which has an effect of 5/10. And then the mode is 5. Oops. Yep, I'm correct. The mode is 5 and 5. With and without, it has 0 effect. The range is 24 minus 2, which is 22 with the outlier. Without the outlier, it's 7 minus 5, which is 2, and that's a difference of 20. So very little effect actually on the median, a little bit higher effect on the mean, but as always, no effect on the mode, and a great, great, great impact on the range. So you guys will practice with this tomorrow. Again, doing the same thing we just did in the guided practice, finding your median, mean, mode, and range with and without, and then the effect, as well as looking at some word problems and determining which measure of central tendency is best for each scenario. And then towards the end of the week, you've got a little project on outliers that you will also be working on. So this is central tendencies and the effect of outliers on central tendencies.